Hi guys, you're welcome back to my channel. In this video, I'll be taking you through arc length. Arc length. So, as part of application of integration, this section deals with finding the length of an arc or length of a curve, right? You know, a curve is an arc, right? It's an arc. So, I have some formula here which you'll be using. It says the length of an arc is equal to the integral of what? Ds. Integral of what? Ds. But what is the x? The x has been defined here for us. So the x is either the square root of 1 plus the expression dy over dx all squared dx, or the ds is equal to the square root of 1 plus the x over dy all squared dy. Okay. Now, what does this mean? So let me graphically explain this concept to you. If you have your coordinates and you have a curve within your axis, this forms an arc, right? This is just an arc, okay? If you want to find the length of this arc, you want to what? Find the entire length of this arc. And this arc here will be bounded by what? The point A and B, okay? And it will also be bounded at the y-axis with the point C and what? D. If I want to find the length of this arc, I can probably take any tangent at any point. You see, at any instant, when I take a tangent, okay, at any instant, let me take a visible tangent here. I'll have getting a triangle, okay. So the tangent, I can complete my tangent to get what? A triangle. And the y component is going to be changed in y, and the x component is going to be what? Changing out x dx, right? Then the actual length of that portion, okay, is just what? The dx, remember, ds, okay. So this is what you're going to get. So, by Pythagoras theorem, the x squared will be equal to what? The x squared plus the y squared. And at this point, depending on the axis which you really want to differentiate with respect to, and that is always influenced by the nature of the function. If your function is in the form y is equal to f of x, then you are going to differentiate with respect to what? X, right? So the y will be changing with respect to x. But if your function happens to be x is equal to g of y, in this manner, your function will be changing, your x will be changing with respect to what? Y. So at this point, we can divide everything here with what? With respect to x. But here we are going to divide with respect to x squared, okay? So we're going to have the x all over what? The x squared over the x squared is equal to the x squared over what? The x squared plus the y squared over the x squared, okay? So once we have this here, then you're going to, you see from here, if I want to do further simplification, what am I getting? I'm going to get the x squared over the x squared is equal to 1 plus the expression. Since I have squared on the numerator and the denominator, I can combine it and give the y over the x. Everything squared. Is that not it? And at this point, what do? I just want to get rid of this squared here. So I'm going to have the s over the x will be equal to the square root of the expression 1 plus open brackets the y over the x all squared. Is that not it? Then my dx is simply equal to the square root of the expression 1 plus open brackets the y over the x all squared multiplying what? Dx. And this is exactly the formula we have up here, right? So this is the proof of the formula I've given, the proof of the formula. This is how it was gotten. So if you want to get this section here, what you do is once you reach this point, you only have to divide through by what? The y squared, and that will make this place 1, and you're going to get the x over the y all squared. Then here too, you just get rid of the squared by taking square root on both sides. So now I have a problem here for us to solve so that you understand this concept well. So let's see. Let me clean my solution here. So this is just the proof. So the problem says we should determine the length of the function y is equal to natural log of sec x, where our x ranges from 0 to pi on 4. 0 to pi on 4. So this is a problem at hand. How do we find the length of this particular curve? Okay, so our curve has been bounded by our 0 to pi on 4. Now, what is the first step in finding arc length? So number one, you realize that in the major formula is what our arc length is equal to the integral of what our dx, and you know the s is this or this. In this manner, our function is y is equal to natural log of what sec x. There are situations where if you take this function in this form, you may be found wanting along the way when you do this square root of 1 plus this expression. For that reason, you would have to make x the subject and change your function into the other form. And as you change your function, you have to change what your limit correspondingly. Okay, so now you let's maintain this, and the first thing is let's find our dy over dx. So remember that if you want to differentiate any natural log expression, you would have to differentiate what is in the argument divided by what itself. When I differentiate sec s, what am I getting? You get sec x tan x. Okay, this is application of integration, so we are not going to expand on how we got this. Okay, all over the sec x itself. Okay, and this is obviously going to give me what tan x, right? This will cancel to give me what tan x, so meaning that our derivative is what equal to tan x. Then we come to find our ds itself. So our ds is going to give us the square root of what 1 plus dy over dx all squared dx, and this is also equal to 1 plus, now my y over dx is tan x. Okay, I'm going to have tan x all squared dx. Now what is 1 plus tan x squared? You realize that there is an identity that 1 plus tan x squared is the same as what sec squared x. So I replace my expression with sec squared x dx, and obviously my square will cancel my square root, and I'll get my ds to be equal to sec x, right? Once you have this, you are done. Dx, I forgot. So you just come straight to the length of an arc formula, which says integral with our upper and lower limit going to be 0 to pi on 4, right, of the expression sec x dx. Okay, as simple as that. So from here, you know that you are just doing some simple integration, and if you integrate sec x, you are expected to get the natural log of what sec x plus tan x. Okay, natural log of what sec x tan x. Then you only have to make substitution to your upper and lower limits, right? So pi on 4. So once this is done, once you make the substitution sec x, we put pi on 4 inside, you are expected to get natural log of square root of 2 plus 1. Remember that tan 45, this pi on 4.5 will be 1. Then sec is to 1 over what cos, right? That was going to be what root 2. Then this is 0. Everything will be 0. That's all. As simple as that, right? So this happens to be the length of the arc. Thank you for being with me in this video. Don't forget to like, subscribe, and share.